Hello, and welcome back to Nature of Code in Rust and GGEZ. We're on to exercise I.6. So this exercise is a little bit tough for me because I'm not exactly sure how to guarantee that my solution is correct. I need to use a custom probability distribution to vary the size of a step taken by the random walker. The step size can be determined by influencing a range of values picked. Can you map the probability exponentially? As in making the likelihood that a value is picked equal to the value squared. So I think that I can take my the random value that's chosen and square it, as opposed to just picking a random value and then picking another random value. Basically, picking a random value, doubling that, and then picking the second random value. I think that that's what that is, but I'm not sure. And I couldn't find solutions in the book. And I couldn't find solutions in the official repo to like verify that that's how the math works. So to sort of check this out myself, I went ahead and I copied example I.2, which is, if we run this, is this the random number distribution. So what I want to do here is I want to make these 100 of these instead of just 20, so we can get a good like look at how the random numbers are sort of like falling, and then we'll do our algorithm to make sure that it at least looks kind of like an exponential graph. So how we're going to do this is, let's see, we need rectangle width. So we have this as 96. If I come here and we do 1920, I can actually, let's do this a little bit more dynamically here. We have this context here. We can get the width and the height, and we're not doing that anywhere. So let's do that here. So let width height equals graphics drawable size and context. And let's say instead of like the rectangle width, we want the count. So this is going to be the rectangle count, and I want 100 of these. I'm going to go ahead and make this a F32. We mostly because we need to do division based upon our width. So if we need to do, so let rectangle width is going to be our width divided by the rectangle count, and that should give us how many how wide we need it each one to be to make 100 of these. All right, so then we're coming down here where we have, let's see, we're going to do the rectangle width. This is going to be just rectangle width. That should be fine here. We give it white because we're giving a random color. Okay, that's fine for all of this. Then, okay, and we're doing the, okay, how are we choosing how long to make this? This is, 20 wide. So we actually need you to be this rectangle count. So I'm going to make you rectangle count as I don't think it matters what you are. U32 maybe? Or do you need to be a U size? Oh, you need to be a U size. Okay, so you're a U size. And we need this, let's see, Vec, you're also a, let's see, is this correct? A Vec, yeah, because I think it's copying it over. So single count as a U size. Okay, then I in 20 is going to be I in single count as, I don't know what you need to be. It probably doesn't really matter. Be U size, that's fine. Then we gen range. Okay, so we create those colors. So if I, and then, rectangle width, you need to be stored away. So let's do going to be an F32. All right, so then everywhere where we have this rectangle width, we're going to just do self.rectangle width. We're happy here. Okay, so let's try running this. See if we now get 100 of them. It looks like we are. And so every single tick, one of them is growing by 1 pixel, depending upon whether or not the random number sort of went into it. And I think in our update loop, it is appropriately deciding, yeah, okay, random index is gen range between 0 and self.heights length. Okay, perfect. So it is auto generating based upon that. So now that we have that, we can actually have our random number generator be a function that we call in here. So we're going to have a private function, and they call this like the Monte Carlo, but we can call this like what is it? It's a exponential random. Call this random exponential. We know we're going to have a reference to self. Actually, I believe we need a mutable reference to self for the RNG. And that should probably be that. We're going to return, I don't think we need to return a result or anything like that. We can just return our usize. All right, so what do we need to do? The idea here is, if we look at our example code, we need to create a random number. Oh, we need to loop forever. So we're going to have a loop. And then we're going to create our first random number. So now we're calling this the probability equals just like the random number. Interesting. They do like R1 equals random, and then probability equals R1. I wonder if I can do that. So if we do like our random, and this is going to be self.rng gen range. We need this to be between 0 and self.heights.length. Okay, so if we do that, that gives us a usize here. Then I want to double that. So that probability equals random. I mean, this really is just random times 2 or random. And if it's multiplied, oh, interesting. Okay. I wonder if I need to like random times random. The problem is if I get something like 75 times 75 is going to be way above 100. So I don't know if that actually works then. Even if I pick a random number and I like add them together, it could easily go over the range that we're looking for, and it will never get chosen. So let me first do it just the way they're doing it. Probability equals random. Then we need a second random number. So we're going to shadow this one. Random equals self.rng generate between 0 and self.heights.length. And then if random is less than our probability. Oh, return R1. Oh, that's why. Okay, so basically we need like random 1, and this is random 2. So if random 2 is less than our probability, then return random 1, which really in this case is just the probability. Now, otherwise, well, okay, we continue until that happens. So this should be fine. Give me random 1. Then down here, we're going to update this. So random index is going to be our random, so self dot random exponential. And then we're going to increase that. And where's our warning? We're not using this height, so I'll underscore that. Other than that, nice, clean, like nice, no errors, no warnings. Let's go ahead and run this and see what it looks like. I think it's more linear than exponential, but we'll sort of take a look at what it ends up looking like. Yeah, this is starting to look a little bit linear to me. It's a lot more likely to get the larger numbers than it is to get the smaller numbers. And that's because if that first number is high, then the chance of getting the second number being lower is actually a lot higher. And of course, if we get something like a 0, then there's no chance that anything will be smaller than that. So we're never going to see we're very rarely going to see something down here. But that does kind of look like it's a linear buildup. And we kind of see that on page 15 of the book. If we come back to here, we scroll up. This is, I believe, what they're showing us. Now, is that true? Yeah, okay. So this is the first, is to get like one simple probability. Now, how can we possibly play around with this to see if we can get like an x squared? I'll go ahead and leave this running in the background. Okay, so if we want an x squared, if we take random 1 and we don't make it the probability, let's say we increase it by half, by like I don't think we can increase it by doubling it. I don't think we can do something like that. What if we increase it by like half of the distance between it and like the 100? So we know it has to be like, it's a random number between 0 and 100, 0 and 99 inclusive. And let's say we get 50. So then it would be somewhere around like 70 something, sort of back of the napkin math. So if my probability is going to be random 1 plus half of the difference between the height, the length, which is then minus what random 1 is. What if I do that? And then it's possible we might be able to get in. Can we get into a infinite loop here if we have like I don't know. I suppose it is possible. So we can do a quick check here. So if probability is greater than, actually no, it won't matter because it's going to make it easier to get the higher it is. Okay. So I think this might work. I don't know if it's going to work for exactly what we want it to look at. Okay, so here we are, this nice even line. Let's run this again. I'm going to run this in release mode because I think it's going to be a little bit faster. We do have to recompile all this stuff, but it's not too many things that we need to compile. All right, we're getting GGEZ, and here we go. To me, this feels like I got it the opposite of what I wanted. This is more everything across the board, and it's a little bit more flat. So, do I want to do the opposite of this? Maybe having this be, let's see, minus here. So this would take the entire length of it minus the random one, so it'd be a larger number. We minus u, so now it becomes harder. Or we could even do, yeah, it makes it harder to hit. So what if I do like random one? I don't want to random one minus random one because that just makes it 0. What if I'm random one minus half of random one? So this would be random one divided by 2. Yeah, this is pretty much just flat. So everything's being chosen. Try this. I would almost assume that if I was getting this correct, I wouldn't be getting so many down near the bottom this quickly. So I don't think this is right either. I suppose also I could take R2 and multiply it by itself. Let's try that. So what if I don't do anything with probability? What if I just leave this alone? We set it to random 1, but then here in random 2, we do random 2, we can just like power times 2. So it times itself, I think. Or we could do it times itself, or we can do times 2. Either, I don't know. Yeah, this is looking linear again, so I don't think I did it right there. It's starting like the window a little bit below the screen, so sometimes it feels like it might be just in a infinite loop, but it's not quite. Okay, so that's, this is getting a lot down below at at like the lower end of the spectrum. A lot more than I was expecting to get. So if we take random 2, power of 2, if that's less than a probability, Then we return random 1. So interesting, that times itself. If that's less than that still gets me a lot down here, which is it's kind of not what I was expecting to get. So I don't think that's right either. So that was random 2 times random 2. We can like double it if random 2 doubled is less than probably return that, and I would assume that it doesn't. I would assume that that's not going to. Why I closed the window. But the other one, like power of 2, should not allow that to pass either. Unless, like, wait, is power 2 times 2 or is it times itself? I thought it was times itself. Maybe I'm like mixing all the math rules together. If I just do times random 2. Yeah, I think that's what we were doing before. We can also we can plus like I would assume that like that it's getting a lot of those numbers way more often than I was expecting it to. Because what I would expect if in like a exponential graph is something like that, and like we'd barely be seeing any of these, and these would be going really fast. That's what I would be expecting. This does feel like it might not be linear, but these are still growing. It still looks like it might be a flat line. There is enough of the variation of random numbers that it's kind of hard to tell sometimes. And I don't know if I need to just leave this running for a really long time to get an actually truly accurate representation. Maybe I should go back down to 20. Maybe having 100 of these is actually too many. Let's say I go back down to 20 and I do the same calculation. I guess so. It should be faster, so we should be able to see patterns a little bit easier. Because it's looking pretty linear right now. Maybe the right's growing a little bit faster. It doesn't feel like exponential growth though. Like I would feel that exponential growth would be really fast compared to the left. But this still feels like a flat line. Let's try some of these. Okay, let's try the doubling again, or the power. So random 2 times random 2. Yeah, this doesn't feel like it's going up like that. It feels like more like a flat line still. And this, when I do this, it actually feels like it's allowing more of the lower numbers through, which makes it like the complete opposite of what I was expecting. Because like if this times itself, if that's less than probability, then return random one. Otherwise, do the entire thing over again. I can cut probability down by like half. But this feels like, if anything, it's the opposite curve that I want. But if I like cut this in half, it's always going to be less than probability. So what if I cut you? What if I like play you by 2? Divide by 2. Just want random. I'm sort of like randomly choosing this. I'm not the best when it comes to these type of math things, so I often do sort of like flail in a dark. Either ask my wife who does have a math major, or ask some friends, find somebody who's already done it online, or just shoot in the dark and see what happens. This could work. Feels like we're getting better growth on the higher numbers this time. Hard to tell if it's truly exponential, but this looks like it might be, because we're barely getting any growth down here, and we're getting significant growth over here. Let's let this play out for a little bit. So it feels close, but not not exactly. Well, I don't know. Maybe it also is just that I'm not recognizing what exponential growth would look like according to this graph. It still feels to me like this is fairly linear. What if I try like dividing by 4, doubling that? Okay, so I'm seeing we're getting absolutely nothing over here, which might be good. So these very high numbers are going to be growing very fast compared to this. So maybe this is what we want. This feels like maybe it could possibly be it. Now, the end goal is to make a random walker that takes a step size based upon it takes a step size based upon the this custom algorithm that we're creating here. So how would we actually do that? We would probably create a vector of points, and then we can draw lines between each of these points, like the previous point and the next point. And that would sort of like give us our step, and it would be like a random step in each direction using this random number for the x and y. I want to say that this is like a lot closer to it's very what is very interesting to me is how it like is in these groups of like 4. And I wonder if that's like the random number generator not being truly random. This does feel like a little bit more curvy to me. So even if it's not correct, I'm going to go ahead and move forward with this. If any of you are watching, you know what the actual math is to make it x squared. Let me know. I'd love to sort of see that. And or if you want to do a pull request into this, I'd be happy to make that change to make it correct. So I'm going to take this one as a random exponential, which I'm going to document as not sure this is really exponential random number generator. Okay, so how do I want to do the random walker for this? So to change this around, I don't need like the heights. We just need like a single mesh, which will just be a mesh. Colors, I don't need like a color. We're just going to use white for this. The background color is fine. RNG, I think we definitely need that stored in here. Rectangle width, we don't need this, but we do need, and we don't need points. Instead, what we do need is our points. And so this is going to be a vector of, let's just have this be the 0.2 from mint. Do I already have this in here? I do not. .2 F32. Or maybe I do. Import you from graphics or algebra. Why can't I find it from mint inside of GGEZ? Usually that's something that I can get. Use GGEZ, mint 2. Unresolved. Unable to find it. I do have GGEZ installed. What am I doing wrong here? Let's go. Oh, apparently I don't have access to mint anymore. Wait, what version of GGEZ am I using? Okay, 0.51. Okay, that makes sense. Run 0.51 here. Oh, is mint no longer re-exported? Did that get removed? I could swear I've been using mint, the mint 0.2 for a while. Re-exports. Yeah, okay, so mint is re-exported here. Mint 0.2. Okay. Are you just unhappy with me, Rust Analyzer? Try restarting you. So I want this to be a mint 0.2, which stores F32s inside. Then inside of here, we'll just sort of fix all of this stuff. We can get the width and the height, and our first point is going to start in the exact center. So let's see. Let's just sort of like reset all of this. Now we're not going to have any view. All we have is our background color and RNG. Okay, so we need our mesh. That mesh equals mesh builder. New, I want, let's see. It's actually going to be a line. It doesn't really matter what this is because I'm going to be overriding it constantly. So you know what? Actually, let's make this be an option with a mesh inside. And we're going to make this just be a none to begin with. So here you go, mesh. All right, RNG. Okay, and then points. So that points is going to be equal to a new vector. And then we're going to have a single point to begin with. That's going to be our 0.2. X is going to be our width divided by 2.0. And our Y is going to be our height divided by 2.0. And we'll throw that in here, points. Oh, I accidentally got rid of background color. Background color is equal to black. Let RNG is equal to red RNG. All right, so that gives that. You're still upset about this 0.2. Well, let's try this again. 0.2. Import 0.2. I can do a graphics 0.2 or an algebra 0.2. What's a graphics 0.2? Go to graphics, structs. Is there a 0.2 here? I don't see anything. I see a point in under rect. Oh, is it like a private type? Now we can pull in mint. That's not a problem. I can also just pull in mint. And we'll just bring in 0.56. And then we can just grab a 0.2 directly from, we'll have to wait until Rust Analyzer is done. Import point. No. Use mint. Oh, what are you? You're in something else, aren't you? There's this vector2. Exports. Use mint. 2. Okay, so you're just a struct mint 0.2. You're a pub struct. Oh, it's from a macro. Oh. 0.2. Okay. Okay. So I should be able to do mint 0.2 like that. So just use that. Okay, 0.2 F32. And okay, so we grab you. Okay, random exponential. So self dot heights, right? So now I want this number to be the difference, like we don't actually know what our max, like we want our max step. You can be like an F32, and our min step can be an F32. Let's say that max step can be equal to, let's do like 10.0, and or maybe even like 50.0 to be very, very like to show very well. And then our min step can be 1.0. Max step, min step, min step, please. View. Okay. Then, okay, so that makes you happy. So we're going to go from our gen range from self.min step to self.max step. Same thing here. Self.min step, self.max step. Okay, so you become happy there. Oh, right, you're going to be an F32 or .0. All right, so we're happy down there. In update, so we want our screen width and our screen height. I don't actually know if we need this at all here. We're gonna get a random index. So this can be a random like X change, and then we want this to be a random Y change. And then I want to update to add like a new point, so that like next point is equal to a 0.2 with an X is going to be the last point. So that's going to be self dot. We can actually get like that last point. It's going to be equal to self dot points of position self dot points length -1. And actually, is there something where I can do like last? Oh, it gives me an option reference. Now we know that there's something always here, so I'm just going to go ahead and unwrap it because it's impossible for that to not get me something. Now are you? It's an option T. You tell me you don't know what this is. It should know that this is a point. Because the points, yeah, because I have points as a vector of 0.2s. Oh, but it's like it's going a little bit weird with the 0.2, and I have no idea if that's actually a problem or not. Okay, so our next point is going to be X is is this last point dot X plus random X. And the more I think about it, we actually need this to be our min step is because we need to choose like which direction we're going, right? This is gonna this is just gonna be the step size. The step size. But we still need to choose if we're going like right or left. Okay, so it's gonna be fine. Let's actually do another random number, but it's just gonna be telling us like are we moving up, right, down, or left. So that random direction is equal to RNG dot sure, we could do a gen range between 0 dot 4. So that should give us something between, okay, that will give us 0, 1, 2, 3, or 4. Then if random direction, so if you're equal to 0, then we're going to move up, let's say. So we're going to say we can have our next point. We can clone the point. So next point equals last point dot clone. Move these both up above here. All right, so we've cloned the next point, and now if we're moving upwards, let's say from the 0, I want to say next point, we're going to need to make this mutable. Next point dot y minus equals, and this is then going to be a self dot random exponential. Okay, else if random direction is equal to 1. Let's say we're moving to the right this time. So we're going like up, right. So next point dot x plus equals self dot random exponential. If random direction is equal to 2, so let's go down this time. Next point dot y is plus equals random experiment, random exponential. Then finally an else. Next point dot x minus equals random. Okay, so that should now set our next point properly. I don't need to do any of this. Instead, what I need to do is self.points.push, and we're going to push in our next point. And then we need to update our mesh. So we're going to do that our mesh is going to be equal to our mesh builder. New, I want to do line. And then it needs to be a reference to the points. That's going to be a reference to self.points. Our width, let's make this like a 2.0 width, and we can make you white. Rust Analyzer, you can't find the color. That returns a result. And then we'll build you and be the context and return a result there. Okay, so that gives us our mesh. There, import you. All right, now we're happy there, and let's go ahead and assign that. So we're going to do self.mesh is equal to sum mesh. Down in draw, we're going to clear the graphics, and then we're just going to say if let sum mesh is equal to self.mesh. I don't want to take ownership of this. I'm going to take a reference. Then I want to do our graphics draw. So graphics draw, pass it in the context, pass it in this mesh, and then we'll do our draw param new, and I think that's it. I don't think we need to do anything else. And all we have yelling at us is this 0.2. I don't think we need this draw mode. We don't need this rectangle count anymore. We don't need this rect. Okay. Oh, and I don't need, it's telling me, oh, using clone on a copy type. Okay. Let's dereference that to force it to copy. Then let's try running this and see what errors we get. No errors, but instead we get our random walk, and we can see that for the most part they're really long steps, but they're every once in a while they're shorter. So everything is working. I guess Rust analyzers are just not really happy with Mint today, but here we go. A random walker with a maybe exponential step size. It really depends upon if I got the math correct for that steps. The general idea is correct, but the implementation details over the math, that may be incorrect. So again, if you know actually what the solution is, please add it into the comments and or feel free to do a pull request or anything else. I'd be happy to accept that. All right, thank you so much for watching this video. I know this was a little bit longer than the previous ones, and I'll see you next time. Bye.